In this video, we are going to solve problem number 9 from the LeetCode, palindrome number. So let's start with reading our task. Given an integer x, return true if x is palindrome and false otherwise. And we have several examples. First, what is exactly palindrome number? So palindrome number is the one that reads the same from left to right and from right to left. For example, 121. And second example tells us that if number is negative, it's not a palindrome. And third example, if the last digit of the number is 0, for example, 10, it also can be palindrome. So you can see that example second and third are very useful because we can immediately say that if number is negative or if it's divisible by 10, in this case this number is not palindrome. But how can we identify all other palindromes? I want to discuss two possible solutions with you. First one is beginner friendly, very naive solution, and second one is more advanced one. So in naive solution, we're going to just reverse our number, reverse x, and if reversed version of our number is the same as the original one, it means that our number is palindrome. So how can we reverse our number? Let's say I have a number 1234 and I want to reverse it. Let's create new variable r, and I want somehow make r equal to 4321. So how am I going to do this? First, I need somehow to extract the last digit of x, 4, and put it to our new value r. To do this, I'm just going to assign to r the remainder of the division x by 10. And the remainder of the division x by 10 is 4. So after this manipulation, r is equal to 4. And since now I don't need the last digit of x, I want now to target our second from the end digit, 3. I'm going to divide x by 10, and after this manipulation, x is equal to 123. Okay, now I want to take digit 3 from x and put it to r. Now to do this, I will multiply r by 10 and once again add the remainder of the division x by 10. In this case, 4 multiplied by 10 will be equal to 40, and the remainder of the division x by 10 now is 3. So now after this calculation, r is equal to 43. And once again, I'm going to divide x by 10 because now I don't need this digit 3. I already put it to r. Okay, and once again, let's do the same with r. Let's multiply it by 10 and add the remainder of the division by 10. And 43 multiplied by 10 plus, now remainder is 2, r is equal to 432. And once again, let's divide x by 10. And after this manipulation, x is equal to 1. So we have one digit left in x. And once again, to move it to our variable r, we will multiply r by 10. And to match our previous equations, we are going to add x, remainder of the division x by 10. So now r is equal to 4321. Okay, now you see some pattern in our calculations. So let's think how to write all this calculation as a loop, as a cycle. So you see the difference in the first equation. We don't have here r multiplied by 10. To match all the next calculations, let's just initialize our variable r with 0. And now we can match it with all the next equations. 0 multiplied by 10 will be 0, so still r is equal to 4. And also to finish the matching, to have all iterations, let's once again divide x by 10. And in this case, x will be equal to 0. So now you understand that we are going to have the next loop. In this loop, we are going to perform this calculation while x is not equal to 0. And in our loop, we are going to repeat these two calculations. We are going to multiply r by 10 and add the remainder of the division x by 10, and don't forget that we need to initialize r with 0. So now you can see our solution in the pseudocode. Now I'm going to move to the LeetCode and implement this solution in Python and C++. If you use different language, please write your code in the comments. Okay, now let's start with Python. I want to write a new function. Let's call it reverse number. And the argument of this function will be x. And inside of this function, I'm going to initialize a new variable r that will store our result, our reversed number. And while x is not equal to 0, I am going to perform our modification. R will be equal to r multiplied by 10 plus remainder of the division x by 10. And I'm going to divide x by 10. And after our cycle is finished, I'm going to return r. Okay, now let's write our main function is palindrome. As you remember from the examples, we know that if x is less than 0 or x is divisible by 10, so it means that remainder of the division x by 10 is equal to 0. But don't forget that x shouldn't be 0 itself, because remainder of the division 0 by 10 is of course 0, but 0 is a digit, so it's still palindrome. In this case, we are going to return false, and we are going to return true if x is equal to output of the reverse number function, else we are going to return false. Okay, now let's submit our solution to see the result. And you can see that for me it's very hard to switch from Python to C++. Okay, now it should be correct. And you can see that our solution is submitted, but our performance, our runtime and memory doesn't show very good results. So we will try to fix it in our more advanced solution. Now let's move to the C++ and let's once again write our naive solution in C++. So I'm going to create a new function, reverse number. It will return integer, and the argument of our function will be also integer. And inside of this function, I'm going to initialize new variable r with 0. And while x is not equal to 0, I'm going once again perform my calculation. R will be equal to r multiplied by 10 plus remainder of the division x by 10. And I'm going to divide x by 10, and at the end I'm going to return r. And in the body of our main function is palindrome. Once again, let's check that our x is negative, or x has digit 0 at the end. That means that x divided by 10 have no remainder, but don't forget that x shouldn't be 0 itself. In this case, we are going to return false. And then after we checked and we reversed our number, we are going to return x equal to our reverse number function outcome. Okay, so if x is equal to the result of reverse number function, we are going to return true. If not, we are going to return false. Let's try to submit this solution. And you can see that I have runtime error, signed integer overflow. So some integer cannot be represented as integer in this solution. And this is exactly why we have our constraints. In our constraints, it was said that x is any integer number. And if, for example, we take the maximum integer, that is 2 billion and something, and if we try to reverse this integer, you can see that the last digit is 7, so reversed version will be 7 billions, and 7 billions is already way too bigger number than our constraints. So 7 billions doesn't fit in the 32-bit integer. You may think that, well, maybe I can use unassigned integer because still we have only positive numbers here, but maximum unassigned integer is 4 billion. It's still too small to match all result of our reverse numbers. So unfortunately here we need to change the type of our function to long. We need to use 64-bit integer. So you can see why the solution is not very optimal, because we need to use a bigger amount of memory to calculate everything. We need to operate here with 64-bit integer, not 32-bit integer. Let's once again submit our solution. And everything is okay. We actually have quite good results. We beat 54% of users with C++ regarding runtime and 60% regarding memory. Okay, now let's think how can we improve our solution. Should we really reverse the entire number to figure out if our initial number is palindrome or not? Let's look closer what's happening in this while loop if we work with the palindrome number. So let's say my palindrome number will be 5445, so 5445. We initialized r with 0, and let's figure out what will happen in each loop iteration. So after the first iteration, we're going to have r equal to 5, and x after the division on 10 will be equal to 544. Okay, what will happen in the second loop iteration? After second loop iteration, r will be equal to 54 and x will be equal also to 54. So you see that when we moved half of the digit from x to r, x and r are now actually equal. So maybe what we can do, maybe we can run our loop while x and r are not equal. So we're going to change our condition while r is smaller than x. So when r is 0, we perform our loop iteration. When it's 5, we perform our loop iteration. But when we have r is equal to 54 and which is equal to x 54, we're going to stop, because now we know that our numbers are equal and x is palindrome. Okay, actually it works when our palindrome has even amount of digit, but what if our palindrome has odd amount of digit? Let's add one more digit here, and let's say I want to work with the palindrome 54,345. So what will happen in this case? So after our first loop iteration, r is equal to 5 and x will be equal to 5434. Still r is smaller than x, so we move to the second iteration, and after the second iteration r will be equal to 54, but x will be equal to 543. Still r is smaller than x, so we are going to perform third iteration, and after the third iteration r will be equal to 543 and x will be equal to 54, and after this we are going to exit our loop. Okay, but now we have this strange situation that r and x are not equal. This central digit 3, it's now at the end of our targeted variable r. So what can we do in this situation? We actually can check that r divided by 10 is equal to x. If we divide r by 10, we are going to remove this central digit, and we are going to stay with the result 54 is equal to 54. Okay, now let's think how we're going to apply this modification of the solution to our code. Let's go back to the lead code. So what I'm going to do, I'm going to move this code here. I'm going to delete my reverse number function, and since now I don't need extra space to store long integer, R will be just integer. And you remember that now we have new condition. While R is smaller than X, we are going to perform this modification, and in the end we are going to return X is equal to R. So if our palindrome has even amount of digit, at the end of this loop, X will be equal to R. But if amount of digits were odd, we are going to perform different check. We are going to check if X is equal to R divided by 10. Okay, now let's try to submit our solution. And you can see how perfect our result is now. We have runtime 0 milliseconds. We beat 100% of users with C++, and we also beat 60% of users with C++ regarding memory. Okay, now let's do all the same modifications with Python. We are going to move cycle here, and I'm going to remove our extra function. Okay, so we have our variable R, and our new condition will be while R is smaller than X. We are going to perform our modifications, and we are going to return true if X is equal to R. X will be equal to R if X is palindrome that has even amount of digits, or if X is palindrome that has odd amount of digit, X will be equal to R divided by 10. Let's now submit this code to check the result, and you can see that now our results are much better. We beat 90% of users with Python regarding runtime and 96% of users with Python regarding memory. Okay guys, I hope this lesson was really helpful for you. If you use different programming language, please write your code to the comments. If you have any questions regarding this task, maybe some ideas, your unique solution that is different from mine, I will wait for your solutions in the comments, and I'll see you in the next lesson.